Hey everyone, John here, senior software engineer with 10 years of experience, and let's practice some Leetcode. In front of us, I have Minesweeper. This can be solved with BFS and DFS if I'm not mistaken. We can look under the topics and see. So we're going to come back and solve this as part of a modified Leetcode kata. So the Latterly Leetcode kata, blog article number 3 on the blog. We're going to do a modified form of this where I'm going to dive in and do linked list cycle just for an easy warm-up. Then I'll do the palindrome linked list or skipped it. I'll do it. I'll time box this one to 15 minutes. So we'll do this, clone graph, and then after clone graph, we'll go over to Minecraft or Minesweeper. So my goal is to get through these 4 in an hour. And I don't know, maybe we'll come back to course schedule or yeah. No, I'd rather spend more time on clone graph and come back and do the BFS. So if I get through these 3 and then I get through Minesweeper, here I'm going to reach for DFS because it's more concise. If I get through those 4, I'll come back and do the BFS form, and that should take up the hour. So we'll start with the linked list cycle. Given head, which is the head node of a linked list, and we can see from the class definition on the right-hand side, this is a singly linked list. We want to detect whether there's a cycle in it. What does a cycle mean? We can look at example 1 and we can see that if we traverse the single direction nodes, we end up going in a cycle. So 204, 204, 204. We get in an infinite loop. So there's a cycle if some node in the list can be reached by continuously following the next pointer. Thanks.
Is this for your treadmill?
Yeah.
It was in the KitchenAid mixer.
Yeah, thank you. So if there is this infinite loop or this cycle, we want to return true, otherwise return false. And we can see that in example 3, single node lists are a possibility, and those will just be false. I guess it could be true if it pointed to itself. So we shouldn't assume, I don't think we should assume. Those will all be false. So what should we do here? We can't cast to a list, because if we try to cast it to a list, we'll get caught in an infinite loop as we go through the nodes and say that node goes over there. We could make a scene map and cache nodes, then return a true if a scene node is seen again. So that would work. That would give us ON time complexity and ON space complexity. But we can do better on memory using fast and slow pointers. There is a cycle if they ever point to the same node. That allows O of 1 space complexity. Thank you for the follow. If you're enjoying the video, feel free to tap like. Make sure you follow the page. Omnish, fast and slow pointer approach. Oh, don't give away the answer, Omnish. Yes, you're right. You're right. I'm glad I wrote it down before I saw your comment. Okay, so let's go ahead with this more efficient way. We make fast, who's going to point to the head. We make slow, who's going to point to the head. We can say, even before we do that, we can say, if not head, return false. You notice that the head here is optional, so it could just be none. If it's none, there's not a cycle. So now we're guaranteed to have the pointers. Because fast is always moving out in front, we're going to do the null checking on fast. We don't need to do the null checking on fast and slow. Slow will always lag behind. So if fast can traverse safely, then slow is guaranteed to traverse safely. So we'll say while fast and fast.next and fast.next.next. So these are the levels of null checking that we're doing. We call it fast because it has to move 2 times when slow is only going to move 1 time in that same iteration. That's why we're tracking .next. Broom, welcome from YouTube. Thanks for being here. He says, do you think 2 months is enough to consistently solve mediums as a current beginner? It could be. It could be. Let's see. If I take the average beginner, and if I think consistently means given a random interview, they will solve the majority under time constraint, I'm going to say that's not going to work. I'm going to say that's not going to work. So I think for the average person, that would not be realistic, but for some people, it will be realistic. Mark, thank you for the follow. If you're on TikTok, by the way, oh, and thanks for the likes. If you're on TikTok, if you'd like to see the full screen, you can check my bio and look for the YouTube or Twitch links. So we've done the null checking within the while loop expression. So we know that this thing is here. So let's go ahead and do the navigation. We want to navigate before checking equivalence. To bypass first iteration. False, true. So on the first iteration, they're both pointing ahead. And we'll get a false equivalence result if we check it right away. So we want to do the navigation first. And we call slow because it only moves once. So if fast is slow, we return true. That's the collision detection. And so if you're familiar with track, someone might be running. There's someone who's faster, someone who's slower. And at this point, they've gotten lapped. So fast has come all the way back around and is parallel with slow. That's like a cycle or a collision. Okay, and then otherwise, we return false. I think that should do it. Great. So we're on time, 5 minutes for the warm-up. Let's go for the palindrome. I'll be time boxing this to 15 minutes. So we'll cut off at 20 if needed. So this is also a linked list problem, but we're guaranteed not to have a cycle. And what we want to do is we want to check whether again, singly linked list pointing only to the right, we want to check whether it represents a palindrome. What is a palindrome? Mom, dad, any singular letter or number, 11, 22. So it's the same forwards and backwards. And here in 1, 2, 2, 1, it's the same forwards and backwards. This is a palindromic singular linked list. Example 2, we can see that the output is false because 1 points at 2, and that's the end. That's not parallel. If you found the middle of that list and you reversed it, it would be not equal. The values would not be equal on reversal. Bathsheba, thanks for being here. Thank you so much for the likes. Okay, and we notice that the node value can go down to 0. That's interesting to note. And I think that gives us enough instruction. Could you do it in O of N1 space? We can. Okay, so let's look through the approach. Intuitive approach, build a string or array by traversal. Then check stir equals stir dot reverse. That takes O of n time and O of n space. So however many nodes there are, that's going to be the length of the string. So it's O of n space. We can do better on space by using fast and slow pointers with in place linked list mutation. We will flip the second half of the list and iteratively compare. values from top to bottom of the list house. O of n time, O of 1 space, just pointers. Okay, so that's pretty efficient. So let's go with that. So what do we have to do? We have to say fast equals head, slow equals head. And again, it's optional. So we'll say if not head, return false. You're not going to be a palindrome. If you have no head, maybe you could say none is a palindrome. It's none forwards and backwards. I don't know. We'll see if our test cases fail. But I'm going to go with that. And I think in an interview, you could just agree on the edge case quickly. Okay, so while fast and fast.next, fast is fast dot. I might want to check next only once, depending on if I want the right of mid or the left of mid in the even case. So 11 is not a good one. It is even, but 1221 would be a better case. You can see there's a left middle and a right middle. So which one do I want to point at? I can control that by whether I check fast.next or next twice. So I just put a to do there. We'll come back and revisit if needed. ABC on YouTube. Hello, hello. So those are our to-dos. And then if we get through the comparison without exiting, so the comparison is going to be like, if you're not equal, you're not a palindrome. So if you pass all those checks, then you are a palindrome finally. Okay, and then here will be our logic to reverse the linked list. We'll do that momentarily. So this is the structure of the solution. Now let's just start implementing. So flip the second half of the list. I can say head of second half equals self.reverse linked list on slow. Do you see why? My fast and slow pointers, when fast hits the end, slow will be at the midpoint. So I can pass slow to the reversal, and it will provide the head of the second half that's flipped. Then my head of first half is just head. We're just getting a new pointer back to the top of the list. Let's do the comparison. So let's say that the reverse linked list is already done. The TikTok live I needed. Welcome, welcome. Thanks for being here. Best TikTok live for coding. Thank you. So let's say that this is already implemented, and we'll just skip ahead to what do I do with it. So now I have the, like in the case of race car, right? It's going to be RAC, and then the other part would flip. So it'll have another RAC. So we're going to flip it and point at them in concurrently. Head of second half and first half are both pointing at R. They're equal, great. We pass the iteration. A, they're equal, great. They're C, great. And so that's how we're checking for equivalence of the character at every index of the linked list. Race car is odd. So it's an odd number. So there's the shared E, right? So there's RAC, RAC, and then there's a shared E. the way that we solve for that is we can either make a copy or we can give a free pass on a none comparison. So that my second list might have one fewer node, and that's just okay. That's just okay. We just give you a free pass. Anything is equal to none. And that's the approach that I'm taking here. When I say while first half and second half, I'm making sure that both nodes exist. If one of the nodes doesn't exist, that indicates an odd case, and it'll just fall through out of the while loop, and they'll just get a free pass on that one case. So that's why I'm writing the while loop this way. Thank you for the follow. Okay, so we're going to say if the values are equal, and is it called val or value? It's called val. So if the value here is not, so in the case of race car, what if it was race cat? Race cat. If R is not, so R and T are not equal. So then it's not a palindrome. Race cat is not a palindrome because that R and that T are not equal. So if they're not equal, return false. Otherwise, we just continue on and we just check the next letter. So let's check the next letter. So now it is next of itself. You see how we're traversing concurrently? Great. And you keep checking until you get through all the letters. And then, okay, by the time you get there, you're a palindrome. That makes sense. This looks good. Now we just need to do our reverse linked list method here. Okay, so priv is none. So when I have this linked list, right, the normal way the list goes is it goes from start to finish, and you know you're done when you hit none. That's the normal way these lists progress. And since we want to flip it, now none actually has to become the first node. So that's why I'm saying previous is none, because I'm going to end up saying like, hey, you wanted to point at the next node. Don't do that. Point back at none, because that's going to be the new top since we flipped it. Does that make sense? Thanks for the follow, Karen and Marwin. Thanks for being here. And thank you for the likes, over 1,000 likes on TikTok. If you recently joined the TikTok, then you can go to the link in my bio and see the YouTube or the Twitch, and you'll be able to see the whole screen a little bit better. This is Python. You can see right here, it says Python 3. And Landon says, what language should I use to solve Leetcode problems? Whatever language you're most comfortable with. So I could solve these in JavaScript if I want, but I will say something like a Java, so a verbose language, is going to hinder you, basically. So I would say avoid Java, avoid C and C-like languages. So JavaScript, Python, I think they're both fine. If you're earlier in your career and you only know one of those languages, just use it. If you're later in your career and you know both, I have found that since I know both, it's actually easier for me to interview in Python because some of the structures and some of the syntax is a little more concise. So now that I feel good with both, I'll prefer Python, but for years I just did JavaScript. Why would those hinder? Just because they're verbose. You just need to write more. And they can be pickier about the structure, and you sometimes need to deal with memory allocation. So in JavaScript and Python, you have dynamic arrays. Like I don't need to specify the array length and stuff like that. Those would be some of the reasons. Okay. So here, making sure my keyboard's working. So while, and let me say current is rev head. So we'll start by pointing at this head that we want to reverse. And then I'm going to say while current. So we're going to go down the list following this current pointer, and I'm going to be flipping it every step that I take. I'm going to flip it. I'm not making a copy. I'm mutating it in place. And then we'll eventually return priv. Why do we want to return priv? Because when current gets all the way to the end, it's pointing at none. I don't want to send none as the head node. I want to do the one before the none. And at that time, it will be priv. So this is the structure of reversing the linked list. How do we do the internals here? So current was going to point at next. Current was going to point at next, and now current.next should point at the previous one. What's the problem here? The problem here is I've created a cycle for myself if I do it that way. So current.next equals previous, and now current equals current.next. I'm just going in a loop over and over. So how do I get out of this loop? I need to have next stored, and I'll call it next. So in Python, next is the name of a global method. I'll call it next node. I need to have next stored by reference, and I can basically teleport after I mutate this. I can basically teleport. So I create that, and I say, hey, my next step is going to be the last node. So I create the infinite loop, but then I sort of teleport to the cached next that I already have a reference to. That's how I solve this cycle problem. So that basically solves it. And then now I just need to make sure that I'm storing the new prev. So the new prev is current. No, now this would be the next node. So let's change the order there. Okay, there we go. And that's how you flip a linked list. So let's check this. That was accepted. Nice. Okay, I went to the 21-minute mark. I said it was going to be the 20 minutes, whatever. I went over. But I think that was useful exercise, don't you? W in the chat if you thought that was fun, reversing a linked list. Okay, so let's go on to cloning a graph. Now we're going to be switching out of linked lists and pointers, and we're going to go into BFS DFS world. BFS DFS world. And then my goal is to get through this, and then I really want to wrestle with this Minesweeper that I haven't solved before yet. But my understanding is it's BFS DFS, so it ties right in. Okay. Now we're on clone graph, and the problem states. Thank you for the W's. The problem states, given a reference to a node in a connected undirected graph. It's an undirected graph. Return a deep copy of the graph. By deep copy, we mean that every node on the graph needs to be a new instance, not just a reference. So a reference graph would be a shallow copy or a shallow clone. A deep copy means we're going to be creating new nodes at every location. Thanks for sharing, Ryan. Okay, let's read the test case format. I mean, it's already dawning on me that DFS and BFS can work. And the key reason that I know that DFS can work is because it's a connected graph. So every node is contiguous to the node that I get a reference for. If that was not the case, I wouldn't be able to use DFS. I might still be able to use BFS, but I couldn't use DFS. I'm not super sure that it matters that it's undirected. Maybe it does. I would have to think about that. Probably it does. Probably it does. I'm not sure DFS would work. Okay, that's right. If the directions were non-uniform, then I would have to alter my DFS. It might still work, but I would need to do some conditions about depending on the direction of pointing. It would still. I think it could still work though, unless you have an inaccessible node. Let me go ahead and draw this out just so that makes sense. I could have a DFS. Yeah, there's a way to do a non-uniform directed graph that DFS would fail. That's possible. So consider the following situation. Okay, cool. We'll do blue is friendlier. Let's do some blues. So here's head. These are all our nodes, right? So currently it's undirected. And so DFS works fine. Now, let me add some pointers. Now, How can I go from A to B using DFS? I guess you still could. It would just be weird. It would just be weird. But yeah, I guess you still could if you had all your conditions set up properly. But it might make your code ugly enough that you might go, let me just do BFS and put these all in a queue. Like, I don't know. I guess you could still do it. All right, anyway, so let's clone this graph. So test case format. The node value is always the same as the index. Cool, that's useful. And the test case uses the adjacency list. This thing is really confusing to me. Not the concept of the adjacency list, but the way the inputs and outputs are expressed. So here it says output is like an empty list of lists. The adjacency list is an empty list of lists, but actually the output should be a node with no neighbors. If you look over here, you should have a node, it should have a value, and neighbors should be an empty list. That's what Leetcode here is trying to say. I think they express it in a really confusing way. Thanks for the follow. And then, yeah, it's interesting to note that you can have number of nodes in the graph 0. So you can have a 0 graph. That's interesting to note. No self loops in the graph is really important. But you can have graph level loops. So here you see 1, 2, 3, 4. And it's circling and it's circling. So there's a graph level loop. So 2 might not point at 2. You don't have a self loop, but you do have a graph level loop. So we need to be careful about that. That means that I need to, remember the linked list cycle? I need something like that. I need an escape hatch if I'm going to do DFS to prevent a loop. And basically, I can just use a cache. Okay, so let's go over here to my notes. As a graph traversal problem, DFS and BFS come to mind. DFS is typically more concise, so I'll target that first. The graph can have a graph level loop, so I need a cache of visited nodes to guard against a cycle or infinite loop. Okay. I must traverse every node in order to copy the graph. So in the worst case, O of n is both the time and space complexity. Does that make sense? User 8.3 and so on. What's the problem? We're doing clone graph. Good old clone graph. Okay, so that is the overview of the approach. And then how do we write this? Pretty much that. Pretty much that. When you implement DFS, you pretty much just call DFS right away. Now, it is the case that node is optional. You can have a 0 graph here. So I do want to say we're going to call DFS if I have a node. Otherwise, return none. And that's really it for the main method. Now I need to go do my DFS. And here, we're going to have a node. So I want to check if I already calculated for this node. And then I want to calculate if needed. And then I want to return the node. Return a new instance deep copy of the node. Okay, that's pretty much it. So here I'll return a deep copy. I'll call it deep copy, and we'll kind of work backwards. So let's return a new instance deep copy of the node. So deep copy is going to be node with value equal to, is it val or value? It's value. It's going to be node.val, and then neighbors. Neighbors is the other thing. Neighbors equal to copied neighbors. So we're working backwards, okay? So that's my deep copy, but now I need to calculate copied neighbors. Copied neighbors is going to be none unless the node has neighbors. So if the node has neighbors, then copied neighbors won't be none. If node.neighbors. Can neighbors be none? Yeah, it can be none. Okay. Else empty list. I don't think it can be none. I think it should be an empty list. Let me put an empty list here. I'll put it as a to-do, but I think if going by the examples, even in the empty case, right, they want you to have an empty list. Juice says hacker status. What up, Juice? Is it cleaner to not name parameters since you can just pass them in some ordi? I love a named variable for readability purposes. So I think it's much, much cleaner to name your name your variables. I'm not a fan. Some of these people chop up their Leetcode and it's just like everything is nested indices on some parent object. No, extract it and name it. Make it readable. Is it cleaner to just use clone graph for the DFS instead of a new function? No, I don't think so. I mean, why would it be cleaner? So you're asking if it's cleaner to include multiple branches of logic in a single method. No, split it out, right? More functions that are simpler. If all you're doing is returning DFS. Yeah, so I'm doing a little bit more than that, right? Not much more than that, but a little bit more than that. So I don't expect to ever return none out of this DFS. It's not a big difference. Like if I'm grading you and if you implement it that way, I'll pass you. It's not a big deal. But I also like the cognitive separation of concern. It's like, okay, this is a DFS. So the readability for me is the real reason that I split it out. Okay. So if the node has neighbors, we need to run DFS on all of them. So we can just say for in neighbors. Self.dfs. This is going to return nodes. And so here we can append the result right there. And when we say calculate if needed, that is the calculation. So we can drop that comment too. What I pass into here is going to be in. And that should return a deep copy of the neighbor. Okay. So the only thing remaining to do is to check if I already calculated for this node. I also need to cache it. So the checkup here, I've processed node map. If process node map, and then we'll return it. If my node is in the map, then we'll return the node index. So nodes, this is going to be hashable because it's a custom object. Stone, welcome, welcome. Thank you for being here. So dictionaries in Python, not hashable, but this is not a dictionary. This is a class instance. Class instances are hashable by default. And you could implement custom hashing if you want to. I don't know what the in Python, we call these like a dunder method. It might be that. I don't know. There's some magic method, but also you don't need to because it's hashable by default. Pedro, welcome. Glad to finally get on Code Talk. Hey, I'm glad you're here. Thinking of a binary tree. Oh, I see what you mean, but I wouldn't want to do a binary tree in this case. But yeah, I see what you were saying now. Stone says, just started Leetcode today. Great to see you streaming. Awesome. I'll recommend again the Latterly Leetcode Kata. Better than the Blind 75, better than the Grind 75, better than Neatcode 150. Start here. It's just 12 problems. Article number 3, blog latterly.io. Okay, so here we did the check, but the problem is we never actually cached anything. So we need to come down here and say node is deep copy. And I think that should do it. Let's see. Oh no, my recursion was too many recurses. Harry, thank you for the follow. Anna James on Twitch, welcome. Welcome from Twitch. Do you care if people put the helper function inside of the parent? I don't really care. My nit would be separate them because in a real commercial code base, you want to separate them, but that's a nit. I understand Leetcode, we do things a little bit differently sometimes. That's fine. Is Python your main code of choice, or what other languages do you know? So I've been writing Python at my current company for the past couple of years, but I have more years of experience with JavaScript and TypeScript. Still, I think that Python is more comfortable for me to do Leetcode in, basically. So what is the issue here? Anna says, howdy. Welcome, Anna. So my copied neighbors.append self DFS in. I know what the issue is. The issue is that the caching needs to happen before here. Cache before calling DFS to cancel cycle, to prevent cycles. And so then we would need to update it. How would that work? I think we will need to update it. So here we'll make it without a neighbor. And then here we will update cache, update node and cache to use to have the right neighbor's value. And we want to update it by ref. Update node by ref. So here's the deep copy. So that we'll just say deep copy.neighbors is copied neighbors. I shouldn't need to go back to the map. It should just be updated by ref. Nice. Ayo, ooh. Beat 99%, baby. Beat 99%. I need a W for that one. Look at that. You love to see it. We're gonna screenshot that one. I'm gonna send this to my mom in an email. I just sent it to myself in an email. I'm definitely posting it on LinkedIn later. Okay, this has been really great. Now it's time to dual. I'm just kidding. It's time to do Minesweeper. Can you explain the last part? What do you mean the last part? Are you talking about this by ref thing? It looks unnecessary. Maybe. So like, what if we do this? Oh, bummer. So you see how if I do that, then my node just doesn't have the copied neighbors. So you definitely need it, right? Is that confusing? Let me know if you can explain what you think is confusing about it, and then I can try to. Oh, you see. Okay, great. Yeah, it's just attaching the neighbors after you calculate them. So up here, we're putting it in this node map so that we can escape out of the recursion. But the calculation isn't quite done. We're just putting in a blocker to escape out of the recursion. Yeah, that's right. Okay, great. Thanks for the follow, Daniel. All right, so let's continue. So we did a DFS. In theory, I can solve this Minesweeper with DFS. So that was kind of like a warm-up. This is the kata mindset, is that you get into a flow of pattern level flow, and then you try different problems in that pattern. In theory, I should be in the flow now. We'll find out. We'll find out depending on whether I bomb this or not. Pun. Unintentionally relevant pun. So let's read the problem first. The problem says, let's play the Minesweeper game. We'll briefly open this. I'm already familiar with Minesweeper, but you might not be. So this is Minesweeper. You click on one of these squares, so it's a matrix. It's a matrix problem. And you see how it explored a bunch of squares around the place I clicked. I clicked right here, but it explored all of these other places. Basically, it's going to look up, down, left, right, and the diagonals, and it's going to automatically click the empty squares. So when I click here, it clicked in this one for free, and then that clicked in these for free, and it clicked in a bunch of these. And it terminates when it runs into these numbers. Okay? And the number means how many landmines are around. And so you see here, there's one, so I know that that's going to be a landmine. And then here, there's one, so I know that's going to be a landmine. Those are 2, and so I know that there won't be one here. This says 4. Here's a corner, and you can basically play off these corners, right? And you say, oh, okay, like there's 1, and there's 1. And you said 2, so you can't have 1 here, you can't have 1 here. And he said 1, so it can't be any of the around those. And that's basically how you play this game. I'm really tempted to like play out this. Okay, well, there we go. I died. So now I clicked a mine and I lost. Great. So there's various states that each of these cells can have. It can be an unrevealed mine. It can be an unrevealed empty square. It can be a revealed blank square, which I think is the same as a revealed empty square. What's the difference between blank and empty? There are rules. Indeed, there are rules. So, and then how many mines, it's a 3x3 area. You're in the middle. So the most it could be is 8 around you, right? X represents a revealed mine. You are also given an integer array click, where click equals click R, click C. What does that mean? I think it just means it's a tuple. Oh, row and column. Row and column. So it's like your XY coordinate, row and column. So it's an integer array, but they're actually going to be like pairs. They're actually going to be pairs. Yeah, which is fine. That's still an integer array, isn't it? It's just linked to every time. So you're going to have your row and your column. Let me go ahead and write that down. Row, column equals click of I. Okay. Great. So that's where they're clicking. I guess they're going to have 1 click per iteration, right? That makes sense. Return the board after revealing this position according to the following rules. If the mine is revealed, the game is over. You should change it to X. I'm just going to literally copy these. Okay, so these are our rules. If the mine is revealed, the game is over, change it to X. And then we'll eventually return board. So that looks like I'm going to mutate it in place. We'll consider the possibility of making a copy board. But for now, I see no reason why not to mutate it in place. Okay, if an empty square E with no adjacent mines is revealed, then change it to a revealed B, and all of its adjacent unrevealed squares should be revealed recursively. It straight up asks for recursion. It straight up asks for recursion. I don't know why it would do that, but okay. Return the board when no more squares will be revealed. Cool. Now, why? Okay, because someone clicked unrevealed mine. You clicked here. So there's just like one click. Am I understanding that right? So this is not solving the whole board because it's leaving that one open, even though it's very clear that you could just click there. And it should be a 1. You could just click there and it should be a 1. Thank you for the likes. Over 3,000 likes on TikTok. Thank you so much. If you're on TikTok, by the way, you can go to my bio, click over to YouTube or Twitch and see the full screen. The stream will also be saved on YouTube. I have a YouTube playlists of all kinds of like development and Leetcode and stuff. So you can just go over to the playlist tab. Here's the Leetcode kata in Java. Here's JavaScript solutions, that is. Leetcode practice, bunch of other stuff. Small group clips. I have a small group where I teach people to code, so you can check that out if you're interested in learning how to code. Project-based learning, that one's not so much Leetcode. Okay. So this is literally going to be one click. So I guess I don't need to for and range it. Yeah, it's not a list of lists. It's just one click. So to do, solve clicked location, and then to do DFS on neighbors. Then return the board. Like that's pretty much it, right? Maybe it's not that complicated of a problem. It's just like a matter of being able to deal with a bunch of rules under a time constraint. Let's see. Do I want to return the board or do I want to return the DFS of the neighbors? The DFS of the node. Yeah, because it will be a recursive click, won't it? So I'm going to click there, I'm going to click there, I'm going to click there. So I can just recursively call update board. So board and then click. I need to click my other directions. I need to click my other directions. And I need to have like already clicked matrix. It doesn't need to be a matrix. It can be a map. It'll have a map of coordinates. We'll just call it scene. Okay. Let me write out my approach. So the approach, recursively, or like DFS. In the worst case, I must click. Do I need to click every node? Is it possible to get empty, like a board that's full of blanks? I think it's possible. At least I didn't read how it was impossible. But wouldn't we treat a click differently than the traversal of the empty spaces? At first glance, I think the answer is no, but I'm open to changing my mind on that. Thanks for the likes. Over 5,500 likes on TikTok. Amodia LZ, thank you for the likes and sharing. Oh, Solution Center, thank you for the likes. Amodia Dia LZ, thanks for sharing. Okay, so in the worst case, I must click every cell. I also want a scene cache of ON minus 1 in the worst case to prevent cycles in the DFS. And ON minus 1, of course, is asymptotically O of n. So time complexity is O of n. You could do this like O rows and columns. So you could do O of n where n is the count of cells, or you could say it's ORC and specify the rows and the columns separately if you want. Whatever, those are equivalent. And the same for space complexity. Okay, so there's our complexity analysis. Now, I want to solve clicked location and then DFS on neighbors. Okay. So let's solve the clicked location. What does it mean to solve? I just want to know, are you a bomb or not? Is bomb equals board clicked row clicked column. Did I spell out the word column? I did. Okay. And is that an E? It's going to be like a capital letter E. It has to be an E or an M. No, these are the possibilities. Okay. So it's a mine, empty, or B for bomb. B for blank. Okay. So if it's an M. So if they clicked a bomb, then we need to basically return the board right away. It's now going to be a revealed bomb, which is the X. Okay. Thanks for the follow. All right. We took care of this rule. Return the board when no more squares will be revealed. That one's tricky. I need to probably think about that a little more. I don't even have energy left to sit. Ooh, bummer. Do you need to go take a nap, or do you need some food or an energy drink? Hydration, maybe. If an empty square with at least one adjacent mine is revealed, then change it to a digit. How do I know if you have adjacent mines? I have to DFS on the neighbors. Yeah, that's weird, right? Because like, how do I pick the order to click the neighbors? Because what if like the right neighbor is a bomb? Then the order that I investigate the neighbors determines when the game ends, right? So I guess I shouldn't click the neighbors. I should just count them. I shouldn't click the neighbors. I should just count them. Okay. So yeah, maybe we should split out this method. I need to know if the neighbor has a bomb. It feels like I'm exploring the whole grid. So I'm confused how in example 2, no one explored 2, 0. Like it almost feels easier to explore the whole matrix than to like, what is the criteria to skip this one? That's what I'm not getting. Okay, so the criteria here is I don't have any bombs around me. I don't have any bombs around me. So if okay, that's it. So a termination criteria is if I deserve an integer. So I'm a bomb or I'm an integer or I'm empty. I'm a bomb. Let's get that. Else if it should have integer value. Else it's empty. Recursively click neighbors. So that's the only case where I apply the DFS, I think. But you don't click. Yes, you only click the neighbors if it's empty. So you'll never run into the case where your chain reaction domino clicks, click a bomb. That just won't happen. That just won't happen. To do get value. So here return board. And then I guess the DFS is count or like click empty tiles using DFS. What you making? We're trying to solve Minesweeper. Clicked empty tiles or click empty tile. Because this is the only case where we're going to return immediately. In the other cases, I think I want to return the integer of bombs around me. Thanks for the follow. All right, we've got 10 minutes left on this before we hit a time box, maybe 15, 10 or 15. Recursively click neighbors. And then I want to return because I'm not clicking anymore. So here I'll return board. So if it should have an integer value, that means I already know. Let's see, I can look around, and if I see even one bomb, then I should have an integer value. I'm going to nest these. I'm not sure it's the right thing to do. Look around for has neighbor bomb. Has a neighbor bomb. That makes sense, right? We'll say this is false. And if you do have a neighbor bomb, return board. Count of neighbor bombs. So it's not has a neighbor bomb, it's count of neighbor bomb. We'll start it with 0. We're going to look around and increment it. And then if that number is greater than 0, I'm going to set the integer and return the board. Else, cur cell is empty, recursively click neighbors. That's right. This feels like the right thing to do. Don't you love that feeling? Don't you love that feeling when you're like, yeah, this is the solution. I might not have time, but this is the right approach. Okay, so here's board and click. So we want to recursively click the neighbors. Right. I need to go like all the directions. So click here is a list of 2 numbers. Clicked row, clicked column. Row is the first one, right? Click R, click C. Yeah, click row, click column. Taran, sup? Clicked row, clicked column. So there's going to be 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. Did I do the right number? 1, 2, 3, 4, 5, 6, 7, 8. Cool. All right, so we click forward a row. We click forward a row and forward a column. We don't click forward a row. We do click forward a column. Great. Now we click backward a row. Now we click backward a row and backward a column. Now we don't click backward a row and we do click backward a column. And then finally, we need to mix them. So we can mix them in either direction, but let's say that we click forward a row and backward a column, and then we click backward a row and forward a column. So those are all the combinations. So those are the 8 Ys around me. They told me to create a project in TypeScript and React, and I haven't touched it in like 1+ years. That's okay. How much time you got? You can brush up in a week. Join the Discord, latterly.io. You can sign up for free, community, join the Discord here. And there's like a coding channel, so feel free to ask for help. I mean, unless they told you like don't ask for help, then obviously don't. But if you you could probably still just ask for general TypeScript brushing up help. So if you just want to kind of do a crash course, feel free to come on by. Okay, so this is going to look around and click the neighbors. Good. That's fine. That's fine. And it doesn't matter what order I click them because none of them are going to set off a bomb because I've already guaranteed I'm empty, which means I don't have a bomb around me. Now what I need to do is count those bombs around me. This is the only piece I'm missing. So how do I count the bombs around me? I need to know, yeah, it's going to be between 0 and 8. I just need to look at them. You could do like if else. You could do like 8 if conditions if you want. I think there's going to be a better way. And it's going to be repeating myself. So like all this stuff that I did over here, I want the same cases over here. So let's make a directions. Let's make a directions. Maybe I don't need the scene map after all, but let's make a directions array. Make a directions array. Okay, so we have you. I kind of like this problem, not gonna lie. At first it was like scaring me, but now I'm like, hey, this is kind of fun. Even if I was in a real interview and they called time like right now, I give it like a 60% chance they would still pass me, maybe more. Because I have the right approach and it's done except for this last bit. Okay, so here's directions. So now what I can say is for D in directions, self.update board D, and I can get rid of all of that. Okay, that's cleaner. And now I can use it over here for D in directions. Wait, why so many directions? Because I need to check all the 8 spaces around me. So check over here. We're going to play Minesweeper. I think you're probably used to seeing up, down, left, and right, but in Minesweeper, we check the diagonals. So that's probably why it's probably twice as many directions as you expected, 8 versus 4. Because we're checking the diagonals basically. Okay, so for each of the directions, if D has bomb, that's a pseudocode. That's a pseudocode. Then we're going to plus equals 1 here. That's basically what we want to do. Now, how do we know if it has bomb? That's because it's going to be equal to an M. If I'm not mistaken, M for mine. And is it correct? I don't think it's correct to say if D has mine. We need to look up on the board. So if D of board is M. Yeah. Oh, these cannot be in this scope because these clicked values are in the lower scope. So let's lower the scope. We'll just lower the scope to right here. What am I pressing? Okay, so we lower the scope to here so we have the clicked rows things. That's fine. Abdul just wrote something crazy on YouTube. What is that? He's trying to say something. I know he is. All right, let's see what's up over here. So expected an indent block. Oh, the curses of using Python. On line 95. Oh, let me go fix line 95. I hate programming. Click empty tiles using D. Okay, do I even need this? I didn't end up using that, did I? I is not defined. Right. List. Indices must be integers or slices, not list. Okay. Is it row column or column row? Row. So we'll call that next row, next call. Okay, so next row. Basically, we just have to destructure it. Next call. This is something that JavaScript could do better. I could just use the ellipsis. So how about that? Next row, next call. List indices must be integers or tuple. Okay, it won't let me destructure. That's fine. Everything's fine. Whatever. This is just a syntax fight. That's all that's going on here. There's not a problem with the approach. List indices must be okay, and that's on me. Yeah, I wrote that wrong. Again, just syntax. It's out of range. Right. Okay, we need to make sure it's in range. That's okay. And I didn't do the guarding over here, like ensure in range. 1, 2, 3. Okay. If next row in board and next call in board of next row and. Okay, so if the next row is in the board and the next column is in that row and the value of the cell is an M, then I want to increment the thing. Thanks for the follow. Okay, so I think that looks good. I'm going to get an error because I need to add the guarding over here, but let's just make sure that that error went away. Does Python like me to put the and over there or something? Is bomb over here? Yeah. So I need to do more guarding. So what do I do if I'm like out of range? I should never actually even visit here. So this error is occurring because of my lack of guard over here. So let's ensure in range. Pretty much I want that same logic, I think. So there's my next row, there's my next column. If the next row is there, if the next column is there, and if the next cell value, like I don't care about that piece. That's the piece that I think can go away. I just need to make sure that the row and column exist. Yeah, let's try that. Okay. Well, I'm wrong, but I feel pretty good about where we got. So my output is a bunch of E's. That's not good. We got this case right. Output. I have a bunch of E's. All of these E's. Expected a B there. What does a B mean? A B means it's blank. Okay, I'm not setting any B's. Cursor is empty. Right. So you're a B. A bunch of these are wrong. So this, portfolio over data structure skills, apply for a niche job that interviews you for the position. What's up, Johan? So 3-0, row column, row 0, 1, 2, 3. So clicked there, and we got the B as expected, but clicking around recursively didn't work. Clicking around recursively didn't work. Why did that not work? So I think I'm going to look up the solution, hit the time box. Let's see, what could I do here that would give me any level of confidence? D in directions. I guess I could just like do a print statement over here. Why not? Print got here. I got a bunch of got here's, right? 1, 2, 3, 4, 5, 6, 7, 8. So it says that it went all the way around. It says that it went all the way around, except they didn't update. Okay, so let's move out of there. Let's just see how many clicks we got. Update board, self.update board. Got here with click. Yeah, so it only got here once. The self is not, it's not getting into that block. So we got here, next row in board. Oh, okay, this syntax doesn't work is probably the issue. Next row in board. Yeah, next row in board is always false. Should I say .get board? Next row .get board. Int has no attribute get. So next row, right. Board.get next row. List has no, okay. So how do I check the index without throwing out of bounds? Yeah, out of range. Okay, I can just look at the length constraints. Board height equals length of board. That's going to be the width. Okay, so instead of next row in board, I'll say next row less than or equal to board height. How about that? True. That looks good. If next row is less than or equal to the board height and next column, and we need to make sure like it's greater than or equal to 0, and 0 is less than or equal to the next column, which is less than or equal to board width. What problem is this? This is 529 Minesweeper. Okay, so I'm gonna look up the solution. I think my guard logic is wrong. Otherwise, I think we're good. Let's look for Python. Okay, so the first thing they do is they check if you click to mine and they return board. Cool. Lambdas. Not here for the lambda. I'm not here for the lambda. I'll keep this open in another tab. If it's like the only one, but I don't really like the lambda syntax. Okay, options. So this is similar to what I did. 0. Okay, and then you just add it every time. That makes sense. Not sure why options is an empty array up here. That's fine. Click 0, click 1, x, y. Okay. So count, they're doing the mines thing. X plus I is greater than -1. So they do have different guard logic. So here's the guard logic. For each option, yeah. I didn't update my guards up here. So let's compare to this guard logic near my got here. X plus I, which is going to be the next. So Y would be your column. So X will be the next row. So if X plus I is greater than -1, and what did I say? This seems equivalent to me. Thanks for the roses. So the next row is greater than -1. The next row is greater than -1. And it's less than the length of the board. Oh, did I just get my X and my Y mixed up? I think I might have just gotten my height and my width mixed up. So X is comparing to the length of the board. And what did I do? X is comparing to Yeah, I got my X's and Y's mixed up. Dang. Next row, D0. 0 is the clicked row. So given a particular row, yeah, 0 is the, so this is going to be a row. This is the first row. So the length of the first row is the width, not the height. Okay. The length of the first row is the width, not the height. We're getting index out of range over here, but that's okay. That still indicates an issue over here. So my next row is it Python? Yeah, this is Python. The X and the Y is confusing me. So he says X, Y, but isn't this the clicked row? Isn't your clicked row going to be your vertical? Python 3 recursive solution, Python 3 recursive solution. Description. Yeah, the first is the row. So given an array of arrays, my 0 row will be like a very high Y. That's just confusing me because XY coordinates, usually X is the horizontal, right? Learning code is really difficult. I feel like I'm not smart enough. Any tips on how to improve? Get with a social community. If you're beating yourself up, then get someone else to help hype you up. Get with a social community. You can sign up at laterally.io, join the Discord for free. And build projects. Don't start with Leetcode. Leetcode is not a good place to start. So you want to like build like a blog, something you already know what it is. That way you don't have to learn the business rules at the same time that you're learning how to code. You can just focus on code. So go to this checklist step by step. It tells you what to do. Also, those search techniques are going to be really, really helpful for you. Because if you're asking like, I don't know what to do, what it really means is not that you don't know how to code. It means you don't know how to search. Because all of your coding questions can be answered through search. So pull up to the website. All right, I'll look at one more solution and then I'm going to have to hop. Let's look at one more solution. I think the X's and the Y's were confusing me there. Step-by-step explanation. Let's do one of these. Check if it's a mine, define directions. Okay, so we check if it's a mine, we define directions. Now we count mines. Cool. DFS, click, click. To reveal empty cells. Okay. So if, and then it just returns empty. Check if the current cell is out of bounds. Yeah, that's maybe the most intuitive way to do it, right? So instead of like, if you're in bounds, do the thing. It's just like if you're out of bounds, return. And since this algorithm operates on the board by reference, if you just return none, you're just not mutating the board. That seems like a better, like a cleaner way to handle it. It's like, let's just make sure that we're safe as a guard clause up front. So the row, yeah, row, column, row, column. So you were just freestyling this. Yeah, pretty much. And I think I got the answer. Like, look, I mean, this is pretty much my answer. The difference is my guard logic was off. And I think it's because I don't know exactly how it was off. Here, let's just throw these in. Can I just throw this in quickly? This is probably not going to work, but whatever. If row click 0 and then call click 1. Yeah, that's fine. Oh, well, it improved it a lot, didn't it? It improved it a lot. Okay, so I'm going to keep this as kind of like my preferred solution. I like this one. Shout out to Marlin09. How do I give you an upvote? I don't know how to give you an upvote, man, but you deserve it. Okay, open you in a new tab. I'm going to copy that. And I typically just stash the solutions right above, like right there. But the key for me, and I always want to learn, when I get it wrong, I want to learn something. The key for me is let's just return none if we're out of bounds. Let's just return none if we're out of bounds. Or if the current cell is not E, which I wasn't guarding against at all. So that's a great step. Hey, thanks for